Today we're looking at the reteach for 6-2 and 6-3, the properties of parallelograms. We know that we have a parallelogram. It's a quadrilateral, which means it has 4 sides, and it has 2 pairs of parallel sides. All parallelograms, such as this one, FGHJ, have the following properties. So some of the properties of these parallelograms. The first one, I'm going to go ahead and label them, I think. The first one is that opposite sides are congruent. I can show that with tick marks, that GF is congruent to HJ, and that GH is congruent to FJ. I can say it in words with a congruent symbol. The second property that all parallelograms share is that the opposite angles are congruent. So angle F and angle H are congruent to each other. Angle G and angle J are congruent to each other. The third property deals with those angles. The angles that are not congruent to each other are supplementary. They add up to 180. So if the angles are next to each other, like G and F, they add up to 180, or G and H, they add up to 180. So between the fact that the angles are either congruent or add up to 180, you can use a lot of information about parallel lines from these angles. The fourth property that all parallelograms share is that the diagonals bisect each other. They might not be the same length, but they intersect at the midpoint of those 2 diagonals. So if I'm going from F to H and from G to J, they intersect at point P. P is the midpoint of GJ and the midpoint of FH, and those half pieces are congruent to each other. So if we're trying to find the measures of parallelograms, I would label, what do I know? I know that if my lines are parallel to each other, the definition of a parallelogram, then the opposite sides are congruent. So if the bottom is 14, the top is 14. If the side is 10, the other side is 10. The question wants me to find the length of segment AB. So the length of segment AB is going to be 10 centimeters. I'm just getting that information from knowing my opposite sides. If I look at question number 2, they're talking about angles. I know that the opposite angles are congruent to each other. So if angle A is 110, angle C is 110. We want to know D and B. If they're not equal to each other, we know that they're supplementary. So I need to take 180 minus 110. If I do that, I get 70. So angle D is 70, angle B is 70. The question is asking me for the measure of angle D, and that's 70 degrees. If I'm looking at questions 3 through 8, it deals with my quadrilateral, my parallelogram, LMNP. And so the first thing I would do is probably label what I see in my picture. If I have a 10 meters on the top, I have a 10 meters on the bottom. 12 meters on the right gives me 12 meters on the left. My diagonals are bisected, so from L to Q is 9, from Q to N is 9. The other thing I know is something about my angles. I know that if I have parallel lines, I have alternate interior angles, those angles that make a Z. And so I can make a Z to show that my angle from M to L to N is 32, just like the angle here. I can make another Z this way to show that if I have 62 degrees here, I have 62 degrees here. Once my picture is labeled, all I need to do is put that information in my answers. So the first question, we want to know what is the length from M to L, and that will be 12 meters. The second question, I want the length from L to P, and that will be 10 meters. I want the measure of the angle from L to P to M, and I've labeled that as 62 degrees. I want the length from L to N. So notice I've got 9 here and 9 here. I have to add the 9 plus the 9 to get 18 meters. I want the measure of the angle from N to L to N, and I've got that labeled as 32 degrees. And I want the length from Q to N. Well, I had to know that was 9 before I could even answer the other question. So I've got all that information. So once I've labeled everything in my diagram, it just becomes a matter of filling in, possibly adding a little bit of information. On the back side, we're looking at Reteach 6-3, the conditions for parallelograms. So I can determine whether a quadrilateral is a parallelogram by seeing if it has these conditions. The first condition is if I have one pair of opposite sides as parallel and congruent, then I know that the figure is a parallelogram. So that's going to be condition number 1. Condition number 2, if both pairs of opposite sides are congruent to each other, then I have a parallelogram. That'll be condition number 2. The third condition, if both pairs of opposite angles are congruent, then I know I have a parallelogram. That'll be condition 3. And the last one, condition 4, if the diagonals bisect each other, then I know I have a parallelogram. We've numbered these conditions so that we don't have so much writing to do in the second part of the assignment. The last condition that they gave us, they said a quadrilateral is also a parallelogram if one of the angles is supplementary to the other, supplementary to both of its consecutive angles. So I know that if I have 115 degrees opposite, I have a 65 here, the other angle has to also be 65 degrees because we already know that a quadrilateral adds up to 360 degrees. And so my shortcut is just knowing that these two add up to 180, these two add up to 180. We can name that condition number 5. If I look at question number 1 on this reteach, we want to show that each quadrilateral is a parallelogram for the given values. In question number 1, all I have are lengths of sides. I have given information that x is 9 and y is 4. So if x is 9, then side from S to T, x plus 3 really means 9 plus 3. Which is 12 units long. If I have 2x minus 6, I really have 2 times 9 minus 6. 2 times 9 is 18, minus 6 also equals 12. So I know that I have two sides that are opposite to each other that are congruent. I need to check my y values. So what I know so far is that the length of RQ is equal to the length of ST. I want to check for my y values. If y is 4, 4 times y means 4 times 4, which is 16. If I have y plus 12, that means I have 4 plus 12, which again is 16. So I know that my side from R to S is the same length as the side from Q to T. And because I have both pairs of opposite sides congruent, PQRS is a parallelogram. So the reason is reason number 2. I'm not writing that whole statement. We have it right up above. If I look at question number 2, I'm given the information that W equals 3 and Z equals 31. So my W's go with my sides, my Z's go with my angles. So if I'm looking at first those side lengths that are involved, If W equals 3, then W plus 7 means 3 plus 7, which gives me 10. If 4 times W minus 2, that means I have 4 times 3, which is 12, minus 2. That also equals 10. So I know that I have two sides that are congruent to each other. I have a pair of opposite sides congruent. So I know that DE has the same length as CF. The other information I have is about my angles. I know that my angle from 2, that labeled 2Z, means 2 times 31, which is 62 degrees. The angle that's labeled 3Z plus 25 means 3 times 31 plus 25. 3 times 31 plus 25 gives me 118. So one thing I know about my angles is that they are supplementary. So I know that angle F plus angle E add up to equal 180 degrees. Those are same side interior angles. Or consecutive interior. We called them both when we talked about our parallel lines. And so that tells me that my lines are parallel. So that line DE is parallel to line CF. If I have one pair of lines that is both parallel and congruent, then I know I have a parallelogram. So that is going to be reason number 1.